Okay, notes for lesson 2.1, part 1. And so you will notice that we are talking about angles and congruence, and a lot of this is going to feel very familiar because it's basically the same kind of ideas we had with our line segments in Unit 1. So our goals today: analyze figures using the definitions of angles and parts of angles, calculate angle measures using the angle addition postulate and angle bisectors. Those should sound familiar. Construct an angle bisector using a compass and a protractor. Okay, so first thing we're going to do is we are going to use a protractor to measure the following angles. Well, first, just to save some time, we're going to measure them in class maybe, but definitely just talk about what kind they are. There are four basic kinds of angles. There are acute, there are obtuse, there are right angles, and there are straight angles. So let's talk about the difference, okay? Now, an acute angle is an angle whose measure is between 0 and 90. So it's greater than 0, but less than 90, okay? Degrees, of course. And then an obtuse angle is the one whose measure is greater than 90, but less than 180. Okay, so they're the bigger, wider angles. The right angle is exactly 90, and we can tell a lot of times that it's 90 degrees based on that. So it is exactly 90 degrees. And a straight angle, of course, is a straight line, and it is exactly 180 degrees. Okay, so kind of just a little refresher. This angle, of course, would be an acute angle. This angle is also an acute angle. We can obviously tell it is not a 90 degree, it's less than that. This one here is obtuse, as is this one. Even though it's like kind of looking upside down and stuff, you can tell it's bigger than 90. And if you couldn't tell, turn it to where you can kind of look at it. And so we can see then, of course, that this one is obtuse as well. All right, so again, we're not going to spend time measuring angles right now, but at least classifying them. All right, let's actually jump into our notes. We have some vocab today, and it looks overwhelming, but I promise you it's not too bad, okay? So first thing we're going to do is we are going to talk about what is a ray. Okay, now the ray is a part of the line consisting of a point on the line we call the end point, and together with all the other collinear points on one side of the end point. Okay, so here we have an example. We have point A. Point B is also on this ray. It is collinear with this on the same side of the ray. Okay, so it is named by the endpoint, and it is named by one other point on the ray, other point, and we use this symbol. Okay, notice there is no dot. We just use that symbol. So for example, this one right here, trying to get that nice for you guys. Okay, this one right here, we would call ray AB. Okay, notice we don't put a point on that notation. And just so you know, we cannot call it ray BA because with a ray, direction is important and we name it with the end point first. Okay, so this is definitely only ray AB. All right. The other thing I want to talk about is something we call opposite rays. Okay. So it is two collinear rays, meaning they're on the same line, and they form a straight angle. Okay. So let's do an example. And of course, a straight angle has a measure of 180. So if I had this ray here and it was ray DB. And I had this ray over here, and we would call this one ray DA. These are opposite rays. Now, we can look at it, obviously, it's just a straight line, it's a straight angle. We could have called that line AD last unit, right? If we're talking about both ends going forever in both directions. But now we're looking at it and realizing that this is actually a ray and this. is actually a ray, and they are going in opposite directions, but they are collinear. They make that straight angle. So we would say ray DA and ray DB are opposite rays. All right. The last word for a second we're going to talk about is just the word angles. We know what angles are, but let's talk about mathematically what's the definition. A pair of rays that have a common endpoint. Okay. And it's called the vertex. So up here we had opposite rays, and what made those unique is that it made a straight angle. Well, anytime we have two rays that have a common endpoint, those are angles. Okay, so here, just to make sure we're clear on some vocab, there's lots of vocab that can happen with angles. Okay, so E, A, F, um, and then one. Okay, just trying to get it drawn. All right, now when we talk about the exterior of the angle, the outside, the exterior, this is what we're talking about. Okay, that's the exterior of the angle. This is the interior, obviously the inside, inside, outside, right? That should make sense. And the way we name it is we name it by a point, then the vertex, then the other point. It has to go in that order. So you could name it, oh, and we have the correct symbol. Okay. So the symbol is this. All right. So we could name this ray, sorry, this angle, angle EAF, or we could name it angle FAE. And sometimes it's helpful to like trace it with your finger to see what you're doing. But we could not call it AEF. It has to go point, vertex, point, or point, vertex, point. Now, sometimes the way they are, you'll see that there are numbers inside. So in this particular case, we could also call this just angle 1. Okay. Another way that we could name this particular angle is we could also just call it angle A. We could name it just by its vertex. Now that only works if the vertex is not shared with another angle. And we're going to look at some examples here in just a minute. Okay, so array, opposite rays, and angles, and just making sure we know how to name them and label them and talk about them. All right, so let's look at example 1. See what I mean? There's lots of things going on. It says name all the angles that have D as a vertex. Okay, so if we are able to look like this, or like this, or like this, or here we have this. Like there are a lot of them. So I'm going to start with the obvious ones and use the numbers. Okay, so I see that angle 6, that's just where my brain went first. Angle 6 does have D as a vertex, right? So does angle 10. So does angle 9. Angle 10, angle 9. So does angle 8 and angle 7. 8, 7. Okay, now that's the numbers that are around there. Let's talk about how we could name them with letters. Well, again, it's point, letter, point. So we could say angle BDC. I said point letter, point, vertex, point. So I could also say angle BDC, right? I could also say angle CDH. It's always point, vertex, point. I could also say angle HDG. I could also say angle GDE. I could also say angle EDB. Lots of names for that one angle. So there's lots of ways that we could address that angle, but they're all talking about they have D as the vertex. Okay, so name the sides of angle 2. Now remember, angles are made up of two rays that are joined together. So when we look at angle 2, the sides, we have this ray here and we have this ray here. So I'm going to say it is ray BA and ray BD. Now, you could have also said angle or ray BG if you wanted to, because it is all on the same line. So you just have to name it with the end point and one of the other points on the line. Okay. So, but I'm going to say angle BA and angle BD. Okay. Um, and I'll put that or ray. BG. I said angle, I meant ray. Okay. All right. So name a point on the interior, the inside of FDE. Do you notice how every time I'm tracing it with my pencil just to kind of figure out what I'm looking at? Because there's so much stuff going on. Okay. So trace it, make it a little darker so we can see exactly what we're talking about. Okay. All right. Name a point in the interior of FDE. Well, a point in the interior inside this angle, there's only one. It's point A. Okay. Be sure you are listing it out, labeling it correctly. Name all the points on the exterior of angle FDE. Well, we know A is on the interior, so what are all the points that are on the exterior? Well, there's not many of them because these lay on the ray, right? So we have points G, we have points H, we have points C. Okay, those are the only three that are on the exterior. Okay. All right, name a pair of opposite rays. Now, there are a lot of options. A lot of options. What we're looking for is a straight angle, and then where we have a common vertex, and then they can go a common endpoint, and they can go either direction. So the one that I'm going to pick, and again, lots of different options, okay? But the one that I will pick is I will say ray BC, because we'll go from here out. So ray BC and ray BA. Because together they made a straight angle, 180 degrees, and they share the common endpoint and they are going in opposite directions. Now, again, there's lots of different answers on that one, but that's the one I'm going to pick. All right. Can a point be the interior of one angle and the exterior of another angle? If so, use diagram 1 to justify your reasoning. Well, of course it can. Okay, so let's look at point H. All right, point H is inside angle CDG, but it is in the exterior of, let's say, for example, angle EDG. So it definitely, oops. It definitely can be. So we could say it's inside this angle, but it's outside this angle. So yeah, that definitely can happen. Okay. So point H is inside angle GDC, but outside angle EDG. Now remember, inside is the word for interior, outside is exterior. Okay, so let's do some examples on how to name and identify. So it says use the figure to name which angle has the sides ray DB and ray DC. We'll go ahead and highlight them. DB right here. Okay, and DC right here. Definitely highlight, definitely darken it in, whatever it's going to take. And so we, of course, can see that that is, we could call it angle 2, right? But we could call it also BDC, angle BDC, okay? And we could also call it angle CDB. Those are the only ones, none of the other names work for it, okay? So just know that there's a lot of different ways to name things accurately. All right, let's do some vocab. This is going to sound very familiar. This is angle addition postulate. Now, just like before, we had the segment addition postulate. This is the angle addition postulate. And you know what? It's basically the same thing, okay? And then we're also going to talk about an angle bisector, okay? So let's go back to angle addition. The sum of two adjacent angles. Now, adjacent is a word for side by side. They are next door neighbors, okay? So the sum of two adjacent angle measures that will be equal to the measure of the angle they form. Basically, little angle plus little angle equals the big angle, all right? So it's not as straightforward as, you know, piece of the segment plus piece of the segment equals the whole segment, but it really is the same thing, okay? So let's look at this picture. If I have angle ABC, okay, and right next to it, adjacent to that, I have angle CBD. Okay, these two angles are adjacent. Angle ABC is adjacent to angle CBD. They are next door neighbors, side by side. They share that common ray. And what it's telling us is that ABC, angle ABC, actually we say the measure of angle ABC, that means the measure of. The measure of angle ABC plus the measure of its side-by-side neighbor, CBD, plus the measure of angle CBD is equal to the measure of the entire outside angle, ABD. Okay? Little angle plus little angle equals the entire angle size. Okay? Now, a bisector, of course, we know what bisectors are. It's a ray or segment that divides an angle into two congruent parts. So we're not doing a segment bisector, we're doing an angle bisector, but we're still doing the same thing, right? So here we have an example. If I have angle EHG and it is being bisected by the ray HF, okay? So we would say that ray HF bisects angle EHG. Okay, so HF bisects this angle. Now, what that tells us is these three little dots in math mean therefore. Okay, so since HF bisects this angle, we therefore know that angle EHF is congruent to angle GHF. We know that this angle is congruent to this angle. Okay, now remember on our segments, what we did was we marked with little tick marks to show that they were congruent. In angles, we call them arc marks because they're little bitty arcs that we draw. So if you see those little arc marks in there, that is your to show that those angles are congruent. Okay? So don't overthink this, guys. This really should feel a lot like what we did in the last unit. So let's look at example 3. It says the measure of angle ADC. Now again, trace it out, highlight it out, whatever you think you need. This angle, the entire angle is 135 degrees. So find the measure of BDC. All right, we'll come back to that in just a second. But look what's happening. We have two angles that are adjacent, they're side by side next door neighbors, and together they make up the entire angle. Okay, the entire big angle. So what do we know? We know that if we take 7x and add to it the other angle, which is 11x plus 9, we are going to get the entire angle, which they told us was 135. Okay, so that's what's happening. And it should feel a little bit like the segment addition. Okay, well, let's go ahead and do this. We get 18x plus 9. Go ahead and subtract 9 from both sides. We get 18x equals 126. Divide by 18, and x equals 7. Okay, now again, that's not my answer because what is it asking for? It says find the measure of angle BDC. So the measure of angle BDC is 11x plus 9, but now we know that it's 7, that x is 7. So 77 plus 9 is 86 degrees. That's my answer. All right. Example 4. In the figure, ray BD bisects ABC. So now that I know those two are congruent, put your little arc marks in there. Okay. And then so we need to find the measure of angle ABC. We need to find the total measure of the big angle. Well, what do we know now that we know that this is the bisector? We know that these two are equal. They are congruent. So I know that 5x plus 2 is equal to 7x minus 6. And we can go ahead and do the math. I'll take away 5x and I'll add 6. Divide by 2, and x equals 4. So again, that's not my answer, but I know that 5x plus 2 plus 7x minus 6, if I add these two together, that's going to give me my total measure, right? But now I know that x is 4. Okay, so that's 22. This is 22, and that should make sense. Like I could have just found one and doubled it since I knew they were congruent, or you can just add it all up like this, but you get 44 degrees. So the measure of angle ABC is 44 degrees. All right, let's look at example 5. In the figure, ray BA and BC, ray BC are opposite rays. What does that tell us if they're opposite rays? It's a 180-degree straight angle, right? Keep that in mind. And BD bisects ABE. So if ray BD is the bisector, that tells us that ABD and DBE are congruent angles. Okay, so lots going on in there. Just draw your pictures. If the measure of ABD is 4x plus 14, and the measure of angle DBE is 8x minus 32, find the measure of angle DBE. Okay, now the fact that they were straight angles and that's 180 degrees, it's good to know, but that's not going to help us solve it right now because what we do know is that these two are congruent, so we can set them equal to each other. So 4x plus 14 equals 8x minus 32. I'm going to take away 4x and I'm going to add 32. Divide by 4, and x equals 23 over 2. Oh my gosh, that doesn't divide evenly. That's okay. You can leave it as 23 over 2 if you want, but for these purposes, it came out to a terminating decimal, not anything that's repeating, so it's okay if you change it to like 11.5. Okay? Now, again, that is not my answer because my question is, what's the measure of angle DBE? So the measure of angle DBE is 8x minus 32. So let's just put that in there. 8 times 11.5 minus 32. And when you figure that out, you get 60 degrees. So the measure of angle DBE is 60 degrees. Okay? All right. So if we knew that BE is the angle bisector of DBC, okay, and we know that this one is 60 degrees, what's this one? Well, it would also be 60 degrees because bisecting break it into congruent pieces. Okay. All right. And that was it. Okay, now we are going to throw in a construction here, and it says write down the steps as you go. There's 6 of them, so you kind of got to write small. And if you got to write bigger and carry it on down here, you can. Okay, so you're going to need your compass, you're going to need your protractor, and this is why it's nice to have those at home because it's going to be hard to do this without these at home. All right, so step 1, make an arc across both rays. All right, both rays. Yes, both rays of the angle, right? Now, did it tell me what size? Nope, so I get to pick. You put your pointy end on the vertex, and you get to pick as long as it goes across both of them. You could make it right there. You could make it out here. I will tell you the bigger the angle, though, it will potentially run off your page. So you actually do kind of want to make it small just for purposes of it not running off your page, not because you have to, because that's how we do it, okay? So you're going to make an arc that goes across both rays. That's what I did, okay? Now, this one is really important. Don't change the distance, which other words means the opening of the compass, right? All right. Don't change it. You left it like this, it stays like this. All right. Now, number 3 says put the compass on the intersection of the arc and the ray, of the arc and the ray, and make another arc inside the angle. That's a lot of writing and a lot of arcs in there, but here's what we do, okay? You did not change the size of what you did to mark your arcs, right? Now, you're going to take your compass and move it up to that intersection, and you're going to make a mark inside the angle. And then you're going to do that exact same thing on the other side. And if you do it right, they're going to intersect. So my number 4 is do the same thing from the other intersection. All right. Now, number 5. We now have an intersecting point, okay? And so we are going to draw a ray from the vertex through the intersecting arcs. Okay, so our compass, good job. We don't need it anymore. So you put a point where your intersecting arcs were, and you line it up with the vertex, and you are just going to draw a line, a ray, because it's not a line, it's got an endpoint. There you go. Okay, and then the last thing that you need to do is mark the congruent angles because now you've broken it into 2 congruent angles. So put your little arc marks there. Okay. Now, I know we did a lot of stopping and writing and all of the things, so let's do this one just step by step. All right. Step 1, take your compass and make, okay, I was trying to keep it the same so you guys could read the steps, but I'm going to have to turn it because it's just easier for me. So take your compass and put the pointy end on the vertex, and you are going to make a line that goes across both rays of the angle. Now again, you can make it whatever size you want, but the bigger you make it, the more likely it is to run off the page. So kind of keep it close by. All right. Do not change the size of your compass. Make marks on the interior from both intersecting points that you had on the when you drew the first arc. And then, man, this is really not focusing today. And then you have a nice intersection. Put a point there, get your protractor. Okay, now we have a bisected angle, and put your arc marks on there to show that they are now congruent. Okay, that's it.